Okay. Became method is introducing the artificial variable and into the objective function. That's a difference. Okay. We'll see on sensitivity analysis. Okay. Sensitivity analysis. What do you mean by sensitive? If I am saying the person is sensitive means what it means. The person will react quickly or react less quickly means uh, he or she doesn't react if the person is sensitive. He will react quickly. Similarly, in our case, these models, sensitivity analysis means we have to check in which regions these will be, the solutions will be affected or the solutions will change. That's the sensitivity analysis. Okay. For here, we can do the changes in parameters where we can do the changes is objective function of the coefficients means we can change. Suppose here, look on here. Wait a minute. Here there's a factory that which I explained the class. For a table we are having profit of $7, and for a char we are where we can change the objective function is the parameters we can change in objective means instead of 7 I can put 9. This is how we are changing the parameters, and we have to see whether this one will affect the our solution or not. And similarly, if you are changing in the right hand side means this one in the constraints. Right hand side of the constraints means the limit we are having. If we are changing this right hand side means instead of 2400 we can put 2500 like that. Or we can change the coefficients in the left hand side of the constraints. But in your book you are having only changing the coefficients in the objective function and changing the values in the right hand side of the constraints. So you don't need to worry about this RHS parameters, sorry, LHS coefficients and combination of these. Okay. If you are asked to change the objective function means they only will ask regarding only with only at a time they will change the objective. If they are asking for RHS means only they will change the RHS parameters. Okay. Here, while we are changing the objective function, the thing only which will be changed is the feasible region won't be affected because the feasible region is determined by which whether objective function determines the feasible region or constraints determine the feasible region. Constraints or objective function determines feasible region. Constraints or objective function determine feasible region. Constraints. Okay. Usually the constraints determine the feasible region. Okay, if we are not changing the constraints means there will be no changes in the feasible region. Where we changing the part in the objective function, then the optimum solution may change. Okay, okay. In here sensitivity analysis, we will check on optimum point, corner point, or optimum point or the extreme corner point, which give corner point which gave you the optimum solution to be fixed. For that we will have a range. Okay, that should be understand through the sensitivity analysis for the optimum point or corner point. Okay, and similarly if you are changing the RHS means we are changing the constraints. What will happen, whether your feasible region will be as it is or it will change or not change? Yes or no? Whether it will change or not? If I change the RHS part of the constraint, it will change. Okay, all the feasible region also change, optimum points also will change. Okay, you also look on up to which how much effective means shadow price means if you are change shadow price, we will study the shadow price in here. Shadow price means how much change in objective by changing one unit in constraint. Okay, that's what we are doing. Okay, the duality is, there's a case of duality. The LP program will always have a dual. If you are doing a minimization, there will be a dual for that. Okay, minimization means there will be maximization. Okay, we will look on deeply on later. Okay, we'll look on the exercise, and by doing this exercise we will revise everything: formulating, solving using graphical method, and how to write the initial table or simplex method, and how to do the sensitivity analysis. In your exams they will ask this way. They might ask you to formulate the LP model, solve using graphical method, or they will ask to understand the simplex tables, the table solved by the simplex method. Okay, we'll look onto that. You don't need to do the iterations. You have to write the initial table and the final table will be given in the paper itself. Okay, and sensitivity analysis also will be look on through sensitivity analysis will be learned through the simplex tables. Okay, okay. First of all, look on to this question. There is a factory producing two types of pen in a factory. we are producing two types of pen. Okay, we can say type A and type B are the two types. Okay, the profit get by selling type A and type B are 5 and 3 respectively. They are getting profit from type A is $5 and from the type B pen is $3. Okay, the raw material used for A is twice the type B. Okay, if I can do two pens in the type B using same amount of material, I can do how many number of type A? If I can produce two type B pens means how many type A pen I can produce according to the statement. The raw material used for a type A is twice type B. Means type A is using 2 times of the material used by the B. Can you understand that statement? So if I can produce two pens in the type B, how many pen I can prepare in type A? Guys, one pen. Why? Two type B pen is equal to one, twice the type B. Okay, so one type A I can produce, and the factory is only having the raw materials. That's enough for how many pens? 1,000 units of type B. Okay, how many units? 1,000 units of type B is available. Okay, the refills means the tube like that. Refills available for the type A and type B are 400 and 700 respectively. Okay, guys, try to formulate the LP model. What I said, to formulate a LP model, first what we have to do, is, if you want to formulate a LP model, initially what should we have to do? We have to find decision variables. Okay, we have to find the decision variables. Okay, here in this question, what are the decision variables? How many decision variables here? And what are those? How many decision variables here and what are those? Two types. Okay, two. There are two decision variables. Those are type A and type B. Okay, so we can, for our EC, we will say A is equal to number of A pens produced. B is equal to number of type P pens produced. Why I am saying A and B means type number of pens produced, type A and type B will be the addition variable. Just look on the question. The thing is, are we changing the number of raw materials, or are we changing the number of variables available? But we are only changing number of pen produced. We only change the number of pens we are producing. So the addition variables will be which we are changing. Okay. Then identify what is our objective. What will be our objective? What will be the objective? What we are talking? Profit or cost or in something else? By changing the number of pens, what we are trying to change? See what details they gave. They didn't say anything about cost. Okay, this is okay. There is nothing stated about cost. Are they said anything about cost of type A or cost of type B? They didn't say. They said in only about profit get by selling type A. That's 5. So 3 is get by type B. So objective will be maximization. So shortly we will say max, or you can write maximize. We will say set, or we can write here profit. For that profit we have to write a function. Set is equal to, how should it will become? Profit is equal to how much profit will be earned by a 1 unit of type A, that is $5, and from a 1 unit of type B we can earn $3. So 1 unit of type A we can get $5, and from type B we can get 1 unit $3. So how many units we are producing actually? Okay, how many units we are producing actually? 8 units, not x, not x, it's I. 5 plus 3, that's right, not x. Those are, we are producing a number of type A pens and B number of type B pens. So 5, how many number of type A we are producing? A, plus how many number of units we are producing in B? So type B, we are producing B number of units. Okay, can you understand? Okay, subject 2. We have to find the constraint. Okay, What are the constraints you are finding? Is there any constraints or not? Guys, yeah, there are constraints regarding raw materials. We don't have any unlimited number of raw materials. We are having a certain amount of raw materials. Okay, and refills. Okay. Okay. Shall we write constraint for the raw material? How it will be? Raw material will be. How many units we are having raw material? That's 1000. It's less than or greater than 1000. Less than, because maximum amount we are having is 1000 units. Okay. Okay. I am saying B. We are talking in the units of B. If we are consuming 1 unit raw material for B, means how many units should be consumed by A? If I am consuming 1 unit for B, means how many units should be consumed by A? Okay. 2. The thing is, it will consume 2 times A plus. Why I am saying here, the thing is, read the question. Okay, it says about 1000 units in which we are saying it's in raw materials in the 1000 units of B. So while we are writing here, we have to write raw materials in the constraints of B units. So if I can produce one type A pen, means we can produce 2 units of type B. So 1 unit used in the type A material means we are using, that's equivalent to 2 types of type B. That's why I put here 2. If I am producing 1 type B pens, means how many units will be used in type B? That's 1. 1. If I am producing 1 type A pen, means instead of producing that 1 type A pen, I can produce 2. That's why I said here 2. Why? This constraint is talked in the units of type B pens. Okay. Raw materials. Okay, careful. So you don't, this is somewhat confusing. Don't worry with that. So usually you will have something easy. Okay. Can you say for the refills how it will be? A greater than or equal or less than or equal? 400. Is the number of, here see, the number of refills we are having for a type A is 400. So suppose you are thinking you are in a factory, you are having refills of 400. How many pens you can produce in type A? Think in that way. You are having only refills, that's enough for 400 pens. So maximum number of pens you can produce is type A is how many? $400. So A should be less than or equal 400. Why? We can only produce the number of pins which are less than or equal 400. Maximum we can produce is 400. Similarly, for B, what will be greater than or equal or less than or equal? How many refills we are having for B? Less than or equal 700. Okay. Why? For a type B pen, we are having only 700 refills. Means you can only produce maximum number of 700. Okay. Suppose I say in our company we are having a policy of to produce at least 100 type A pens. At least. That means what? Minimum of 100 pens. So in that case, what will be the constraint? We have a policy of making at least 100 pens. Type A pens. Sorry, 100 type A pens. Guys, there's I am additionally, yeah. Additionally, I am asking if our company has a policy, means if there's a rule, we have to at least produce type A pens at least amount of 100. Type A pens should be at least 100 to be produced. In that case, what will be the constraint? Not less than or equal in here. Here. I am saying at least 100. At least 100 type A, a pen should be produced means A should be greater than or equal 100. Why? I should at least means minimum I have to produce 100 pens. So I have to produce more than 100. Clearly understand what is at least. At least means this is the minimum amount you have to create. At most means that is the maximum. Okay. Clearly understand what is at least and at most. At least means this is the minimum amount you have to produce. So minimum amount we can produce this 100 means anyhow we have to produce more than 100 pens. Okay. Can you understand? Okay. Okay, fine. So additionally, I have said this one. Along with these, there will be one constraint more to this. What is that? Whether A and B can take all the values or certain values. Guys, in the real number, whether A comma B can take all the values or certain values. Whether A and B can be negative or positive, or can be either negative or positive. positive values. Why? The number of pens are the real number, that's positive numbers. Whether you can say -2 pens. Can you ask in a shop, can you give me -2 number of pens? Yes, no point. Okay. So there will be additional constraint comes what a comma b greater than or equal 0. We will say it has non-negativity constraint. Okay, don't forget to put this one. Okay, we have formulated the LP model. You have to first find the decision variable and you have to write objective function. Thereafter, you have to write the constraints. Okay. Next, solve using graphical method. Okay. First, we will go to the question. Whether this can be solved using graphical method or not. First of all, identify that whether this can be done by graphical method or not. Whether it can be yeah. Wait a minute. How did you come up? Okay. Why I am saying this is non-negativity constraint means A and B is what? The number of type A pen and number of type B pen. Okay. So see, if you are going to ask in a shop whether you will ask a negative number of types, sorry, negative number of pens or positive number of pens, you will ask positive number of pens, not the negative. There will be no negative values for the A, B. There is no possible. Okay, that's why we are saying non-negativity, or means we can say it's positive. Saying it as non-negativity, the A and B can't take any negative values. A and B can't take any, cannot take any negative values. That's why we are saying non-negativity constraint. So we usually say in the non-negativity constraint should be always be in their models. Okay, here solving using the solve using graphical method. Whether this can be solved by the graphical method or not, guys. Okay. Yes, it can be solved. How you are saying this can be solved using graphical method? Okay. How you are saying this problem can be solved using graphical method? How you are saying? Since it's given by in linear programming model, we can do it, or is there anything else? because there is two variable only. Okay, the thing is, important thing is, number of decision variables in here is only two, so it can be done. Can be done because we are having two decision variables only. Okay, it can be done because we are having two decisions variables. So next, what should we do in graphical method? We have to draw the constraints and we have to identify the feasible region first. Okay, how to draw that graph? Okay, we'll look on first. There will be two axes. Draw initially, first draw two axes. Okay, draw this. Okay, okay, okay. Here we will draw two axes. Why these two axes? One axis is for one variable. Okay, what are the variables we are having? A, I am getting B here and A here. There is nothing wrong with interchanging. You can have A there and A here and B here, anything else. So one axis is for type B, means this is means we can have the number of pins in this axis and number of pins in this axis. Okay. First of all, initially, whether there is a possibility to get the values in this region or this region or this region. Is there any possibility? What will be the values in this region for B, down part in this region, whether it's negative or positive value? Negative. So similarly for A, to the left side of the this axis will be negative value for the A. So by non-negativity, the only feasible region is where this part, okay, in this area. Okay. Then we have to draw a line for a less than or equal. First of all, we will draw it for these constraints. Okay. How to draw those lines? Okay. First, 2a plus b less than or equal 1000. How to find that line? Is it a one line or is there will be many lines like that? Less than or equal 1000 means. Two a plus b less than or equal 1000 means there will be huge number of values. So we are saying one line, that's fine. When we are saying that's one line means we will, for graphical method, if there's a constraint say this way, you write it in a, to draw the graphs only you will write this way. Okay, no need to write, just for an idea you just think this is the line. Similarly for this thing, a equal 400, for b it's equal to 700, like that. So in your O level, you will be drawn these lines. 2a plus b is equal to 100, something like y plus 2y plus, sorry, b is something like y and a is something like x. 2x plus y is equal to 1000. mx plus c is equal to y is equal to mx plus c, something like that. So how to draw that? For here, I will show the easy way. For the first, we will draw it will be a slope like this. Okay. First of all, find what is the value of b when a is 0 in this axis. What is the value of a in this axis? What is the value of a? $500 is, sorry, here in this axis means this is axis of b. So in the axis of b, the value for a should be 0. So by substituting 0, what will be the value for b? That will be 1000. There will be a cutting point like this here. Just put it like here, a mark 1000. Similarly, in the axis of a, what will be the value for b? In the axis of a, the value for b will be 0. So by substituting 0, you will get value of a is equal to 500. Okay. Just mark here 500. Something like here, you will mark a 500. So by joining this line, draw a line. By joining this, draw a line. Okay. I draw a line. Okay, fine. Where the feasible region is in this side of the line or this side of the line. How to find that? Right hand side, sorry, left hand side of the line or right hand side of the line. How to find that? Under that line. That means left hand side of the line. This is the value of here. It is b is equal to 0 and 500. In this side, what will be the value? To find which side that line belongs. Oh, okay, wait a minute. Someone is not understanding how I got this 500 and 1000. Okay, I will repeat it. Okay, we'll see. Guys, look on the table. Sorry, this chart. The line is 2a plus b less than or equal 1000. To draw the graph, just think the line is 2a plus b equal 1000. We want that line. Okay, here this is the axis of b. Okay. This is the axis of b. Here, come here. This will be 0. 0 means the value here is 0 for a and 0 for b. In this line, what will be the value for a? A will be 0 and b will be changing. Similarly, in this line, what will be the value for a? A will be changing, but the value for b will be 0. Okay, to find this value, I will put for this in this line, the a will be 0. So put a 0. 2 into 0, 0 plus b is equal to 1000. So then b will be equal 1000. This will be exactly as I have to write is 0 comma 1000 actually. Okay, and here this will be what? In this axis b will be 0. So substitute here b 0. So what will be the value for a? 2a equal to 1000 means a equal to 500. So this line will be 500 comma for the value for the b is 0. Okay, I am writing in the graphical notation. Okay guys, can you understand now, or do I need to repeat it again? Okay, we'll see here now how. So the thing to understand how which region should be feasible or not, or that, take here, come here, this point here will be 500 comma 0. For next to this point, the 1 unit next, what will be that coordinate? What will be the coordinate next to this right hand side of this point? guys, this the coordinate is 500 means next to this will be 501 comma 0 means that means for the A value will be 501, for B 0. Similarly here 499 comma 0. Substitute in this inequality. Which side you will, okay, here that 500 pence produced. That means this point means. So I am trying to figure out which above this line or below this line should be feasible region. To find that, we have to put a value and we have to check whether that conditions satisfies. Okay, to the right to that point is 501 comma 0, to left is 499 comma 0. Substitute here, which will be satisfied, right hand side or left hand side will satisfy. Yeah, left hand side will satisfy. If you put 501, this will be 1002. 1002 is not less than 1000. Okay, left hand side will be satisfied. So this triangle will be feasible region. So additionally, we have to draw line for A equal 400. How to draw that? A equal 400. Whether it will be vertical line or horizontal line. Vertical or horizontal line. Guys, we'll see. A equal 400 means A should be constant and B should be changing. That's not horizontal line, that's vertical line. According to this graph, if you take a point here 400 and here also A will be 400, 400, 400, 400, but B will be changing. So that will be the line. So that's not horizontal, that's vertical line. Careful with the lines. Okay. This will be that A equal to 400. So what will be the point where it intersects? This will be 400 comma 0. How to find this one? This coordinate. In your O levels, how did you find the intersections? Yeah, by solving this line and this line. This line consists A is equal to 400. See, here is 400, here is also 400, but B values will be changing. At this point, A is equal to 400. So substitute by solving this equation and this equation. By solving these two equations, you will get the value. A is equal to 400. So substitute here. A is equal to 400 means this will be 400 comma, for the B it will be 200. Okay. Okay, fine. Then what will be this? B less than or equal to 700 means B equal to, sorry, next we have to find the feasible, the new feasible region, which will be to the line to the left or right. Less than 400 means A will be less than 400 in this region. So left region will be the feasible. Okay, so this will be the feasible region. Okay, fine. Okay, we have to draw the line for this last constraint. B less than or equal 700. This will be horizontal or vertical line. That will be horizontal line. Okay. It comes. Okay. It will be here. This will be 0, 700. And this point will be, the intersection point will be what? What will be the intersection point? This one. This point. By solving this line and this line, that means b equals 700 and 2a plus b equal 1000. By solving this one and this one, we can get the values. B equal to 700. So okay, fine, 700. What will be the value for a? B equal 700 means 2a equal to 300, a equal to 150. Okay, 150 comma 200, sorry, 700. Okay, now say whether region above to this line or below to this line is feasible, above or below. Below the line. The reason is we should be less than or equal 700. So if you go in the above, you will get the value for B is more than 700. So to get less than 700, this is the region. So finally, this part will be this. This shape should be, sorry, I couldn't fill that part. This should be the feasible region. What are the corner points? This one, this one, this one, and this one. Okay, these will be the corner points. Okay, so we have drawn graph and we have found out the extreme points. So okay, so okay, did we drawn all the constraints or is there anything remaining? I have drawn for this one constraints. Okay, fine. A also fine, B also fine. What about this one? A comma B greater than or equal 0. Did I drawn or not? Did I drawn or not? Drawn. The thing is, in the start, yeah, or you can say it is 0, 0 is the origin graph. The original thing is, I have decided the axis part. I have only taken this part only, not taking this or this region. Why? Those are non-negative, sorry, negative parts. This is the region where A comma B is greater than 0. Okay, I have selected this space. This is the positive region. Okay, fine. Then what about the profit line? Is there anything to be done with this profit line or not? Do I need to draw the profit line in the graph? Guys, do I need to draw the objective line or not? Okay, we'll see whether we can draw the objective line or not. How do you draw this one? 5a plus 3b equal to set. What is the value for set? Do you know the value for set? Do you know the value for the set? We don't know the value for the set. So without knowing that value for set, the drawing of profit, sorry, objective line is impossible. That's why we are saying isoprofit method, isoprofit line method. So that's somewhat difficult to understand. I will say it later. Okay. First of all, we only need to draw lines for constraints only. No need to draw it for objective. Okay. Then how to find the optimum solution? How to find the optimum solution? Here, I said there are 1, 2, 3, 4 corner points. Along with this one, there will be additional 0, 0 also. Okay, check for code. Zero, 0. Okay. So considering these, will go optimum solution. Write all the coding, all the optimum, sorry, corner points. 0, 0. Another one is 0, 700. Another one is 700, so 150, 700. Another one is 400, 200. And the last one is 400 comma 0. Okay, fine. But this 0 means A is equal to 0. But this 0, B is equal to 0. Here, A is equal to 0 and B is equal to 700. Okay. For this one, you have to calculate what is set. Similarly, for this one, for each corner points, you have to calculate what is set. How do you calculate Z? What is this set? Set is the okay. This is set. Okay. How to find it? 5 times 0 plus 3 times 0. That's equal to 0. Similarly here, 5 times what is the value for A? That's 0. Plus 3 times what is the value for B? That's 700. That's equal to 2100. Okay. Similarly, this one 5 times how much? 150 plus 3 times how much? 700. That's equal to 5 into 150 is 750 plus 2100, 2850. Okay. Similarly here, 5 times A is what? 400 plus 3 times B is what? 200. That's 2600. Similarly here, set equal to 5 times 400 plus 3 times 0. That's 2000. Okay, fine. Okay. What is our objective? Maximize or minimize? What is our objective? Maximize or minimize? Maximize. So, which should I choose? Which should I choose? Among these, which one should I use? Minimum value of set or maximum value of set? Maximum value of set. Okay. I have to choose the maximum value of set. So, optimum value is, okay, what value is set? Optimum profit is, optimum value is set is equal to 2850, where A equal to how much? How much A and how much B should I produce? 150 A's and 700 B's. Okay, you have to write this way. A is 150 and B is 700. Okay, I have to produce 150 units of A and 700 units of B. I have to produce. Okay, fine. That's all with the graphical method. Now we will look on to the simplex method. Okay, how to write the simplex method, how to solve using simplex method. So using simplex method. Okay, fine. Here objective is right. subject to constraints. For the simplex method, whether the constraint should be in the inequality or equality, whether it should be unequal constraints or equal constraints. The thing is, the simplex can only solve for the equal constraints, not for the unequal. So be careful. You can't do with this one. So you have to change this. Okay. How to change? I said early. How to change? Guys, wait a minute. There's a one person asking with a how okay. Here, see, in these points, you know how to get the corner points. Okay, you are okay with that. How you got corner points? By solving the lines. Here will be 0 700, and by solving this line and this line, you will get the corner points 150 700. Similarly, this line and this line, you will get 400 200. Okay, fine. These are the corner points. That means extreme points for this region. See, for the feasible region, which are the extreme points? This one, this one, this one, this one, this one. Those are the extreme points. So I will write it here. Here, C 0 0. What it means? 0 of A, B is equal to 0. Here, in this point, what will be? A is equal to how much? 400, and B is equal to how much? 0. Similarly, here A is equal to 400 and B is equal to 200. Similar like that. A is equal to 150 and B is equal to 700. Similar like that. A is equal to 0 and B is equal to 700. So I am taking those extreme points. This is we say it as corner point method or extreme point method. Okay. By substituting in the objective function. What is the objective function? Z is equal to 5a plus 3b. For here, for the first point, what is the value for A? A is equal to 0. What is the value for B? B is equal to 0. By substituting A 0 and B 0, we will get Z is equal to 0. Similarly, here A is equal to 0 and B is equal to 700. Substituting, we will get 2100 for this equation. Similarly, here A is equal to 150 and B is equal to 700. By substituting A 150 and B 700, we will get 2850. Similarly, for 400, 200, here A is equal to 400 and B is equal to 200. Among this set 0, 2100, 2850, 2600 and 2000, which should I choose the maximum amount or minimum amount? I have to choose the maximum amount. Why? The problem is maximization. Okay, so I have to choose the maximum value. Among these 0, 2100 and 2850, 2600 and 2000, I have to choose 2850. Okay, then optimum profit I can get is 2850. For which values of A and B? See the coordinates. A is 150 and B is 700. Okay, fine. That's the thing. We'll look on here. How to, whether we can do it through the simplex method or not. we can't do this one using simplex method. The problem is these are inequalities. So we have to, before going to that simplex method, we have to make these as equal constraints. How to make this one equal constraints? 2a plus b less than 1000. Then do we need to add or subtract variable? Add or subtract? To add plus is 1. Okay, equal. To make it equal, I have to, similarly for this one also, I have to add a variable. For this one also, I have to add the select variable. Okay. Again, here, what do you say about S1, S2, S3? Those also non-negative. Don't forget to say these also. Okay. S1, S2, S3 also will be non-negative constraints. Okay. Here. Okay. How to write the, to draw it as a chart and trying to use the Excel. Sorry. Okay. First write the variables which are here. A. The next variable is what? B. Next is S1. Sorry. S1, S2, and S3. Okay. Here write Cj. Here we will put CB. Okay. Yes. Here. First of all, we will write first constraint. What is the first constraints? So, addition to this RHS. Okay. First of all, we will write the first constraint. What is the first constraint? 2a plus b plus s1 equal to 1000. How many a's there? 2. How many b's there? 1. How many s1s? 1. How many s2s? 0. How many s3s? 0. What is mean by RHS? The right hand side value of the constraint. That's what 1000. Okay. Here we will say the basic variable is S1. So write here S1. Okay. Next to this S2. Okay. Second constraint is A plus S2 equal to 400. How many A's there? 1. How many B's there? 0. How many S1s there? 0. How many S2s there? 1. How many S3s there? 0. What is RHS? 400. Okay. Similarly, next constraints will be the S3 will be basic. So we will write here how many A's there? Zeros. How many B in the third constraint? 1. How many S1? 0. How many S2? 0. How many S3s? 1. What is the RHS? 700. Here. What is this CJ? What is this CJ? We'll see. Cj is the coefficients of A, B, S1, S2, S3. What is a coefficient? Coefficient means that part before the A. What is the coefficient? That's 5. What is the coefficient of B? That's 3. What is the coefficient of S1? 0, S2, 0, S3, 0. Okay, here we'll see. What is the coefficient of S1 in the objective? That's what is the coefficient of S1 in the objective? How to find that? CBs, what is the coefficient of S1 in the objective? Zero. Similarly for S2, 0. Similarly for S3 also 0. Okay. Suppose here is a variable like A is the basic, then what will be the CB? Suppose think this one is A. What will be the CB here? Suppose this is A. Then this is 5. Okay. Fine. Okay. Then here we will say set I. Okay. How to calculate set I? We'll see. Set I is you have to just this one is equal to this one is how its get is 2 into what is the value here 0 plus here 1 into 0 plus this one is 0 into 0. Okay, then how it will become? Then for this point how it comes 1 into 0, 1 into 0, here 0 into 0, here 1 into 0 plus. Similarly for here how it's for rest of the value, what will be the value, guys? For this one, how it will be? Guys, how to get the value for here? Here will be how to get it 1 into 0, 1 into 0 plus 0 into 0 plus this one 0 into 0 again. Okay, so for all these rows the values will be what? 0. Why? All are multiplied and added by multiplied by zeros and added, so it's 0. Then how to find Cj minus set I? Okay, how to find? So, okay, fine. What will be here? Cj is 5. 5 minus, what is the set for this? 0. That's equal to what? 5. Then, guys, for this one, what will be the value? Three. This will be 3. This will be 0. This will be 0. This will be 0. And what this will be 0. Okay. This is the initial table of your simplex method. Okay, guys. This is the initial table of your simplex method. Okay, guys, if you have any doubt regarding that initial table of simplex method, can ask. Okay, do you have any doubts, guys? CB. Okay, fine. How I get the value for CB? CB is the coefficient of the this one, these basic variables. For S1, what is the coefficient in objective? Go to the objective function and see what is the coefficient for S1. For the S1, what is the coefficient here? For the S1, what is the coefficient in the objective function? Guys, see the objective function, whether this one has S1 or not. No, there's no S1. That means we can write 0 times S1 like that. Wait a minute. 0 times S1 plus 0 times S2 like that plus 0 times S3, something like so. Here, for the coefficient of S1 in the objective is 0, for the S2 is 0, similarly for S3 is 0. Suppose here I am having, instead of S3, if I have A, sorry, if I have B, what will be the CB here? What will be CB? That's 3. Why? The objective function, it has 3. Okay. This will be 3. Okay. Okay, fine. Then, guys, do you understand how I write it here? The first constraint should be write it as the coefficient of A is what? 2. That's why here 2. Similarly, in the first constraint, what is the coefficient of B? That's 1. That's why I put here 1. Similarly, for constraint, sorry, in the first constraint, what is the value for coefficient for S1, that's 1. S2 is, there's no S2 here, so that's 0. Similarly, S3 is 0. RHS means the value in the right hand side. Okay, that's 1000. Similarly, for the second constraint, I will write what is the coefficient of A, that's 1. B is 0. S1 is 0, there is no S1. So similarly, S3, sorry, S3, S2 is there 1 and S3 is not, and that will be 400 right hand. Similarly, for the third constraint, what is the coefficient of A here in this constraint? That's 0. B is 1. S1 is 0 and S2 is 0. S3 is 1. Right hand side value is 700. How I calculated this 0? This 0 is calculated by multiplying this 2 0 plus this one into this plus this one into this. For this one, I have to multiply 1 into 0 plus 0 into 0 plus 1 into 0. That's addition is 0. Suppose here is 2. Suppose think like that way. Suppose this one is 2. What will be the value here? Why? 2 into 1 is 2 plus 0 into 0 is 0. 0 into 1 is 0. So this will be 0 like that. Okay. Fine. Okay. That's how we calculated SAT. How I calculated Cj minus SAT by subtracting this one from this value from this. 5 minus 0 is 5. Similarly here, 3 minus 0 is 3. Similarly here, 0 minus 0. For here, 0 minus 0 is 0. 0 minus 0 is 0. Here is 0 and here also 0. Okay. Fine. This is the initial table of Ewers. So okay. Okay, guys. If you have any doubts up to this, you can ask. Guys, if you have any doubts up to this, can ask. Okay. I will again explain how we get SAT I here. SAT I is calculated by multiplying this. For this one, you have to look on this column. Okay, 2 times the respective value is here is 0. 2 times 0 plus 1 times 0 plus this one is 0 times 0. Okay, so by solving this one you will get 0. Similarly here 1 time 0, similarly 0 into 0 plus 0 into 0 plus 1 time 0. Okay. By solving this you will get 0. So similarly here also you will get 1 time 0 and 0 time 0 plus 0 time 0 plus this one 0 times 0. Okay, by solving this 0. That's why all the values in this row is 0. Why? Your every parts are multiplied by 0 0 0. Okay, then by getting these sati's you can directly get ci minus cj minus sati. How? Okay, by subtracting this is cj 5 minus this one 0. 5 minus 0 is 5. Similarly for this one 3 minus 0 is 3. Okay, similarly you can get it. Okay, this is the initial table. Okay, okay, I will explain those sensitivity analysis and duality in the next lectures. Okay, if you have any doubts up to now you can ask, or otherwise you can